Hello, Algebra 2. This is going to be your notes number 34. We're switching gears just a little bit. We're going to be doing graphing quadratics. So the essential question is, how do you graph a quadratic function into a parabola using only a, h, and k? And you have done this before in geometry, so hopefully this will be somewhat familiar. So at the end of this lesson, you should be able to say that you can graph a quadratic function using key features including the vertex, transformations of the parent function, the zeros, and the y-intercepts. There's no homework tonight. We will practice this work more tomorrow. Okay, so I'd like you to just sit and listen for just a minute and read this slide with me. So this is talking about the vertex. So you can see the shape of the red graph. One is pointing down and one is pointing up. That is a rounded shape. This is no longer V-shaped. So this is a smooth curve and it's called a parabola. So parabola is the name of this graph, parabola. It comes from a quadratic function. And here, what I'm putting a box around is the quadratic function. And you'll notice that this has parentheses. It does not have straight bars. And it also has this little square right here, the number 2 exponent. So this is the basic form of a quadratic equation, and it graphs into a parabola, the red graph. So make sure that these graphs do not have a V point like our absolute values did, okay? Okay, so there's always a lowest point or a highest point. The lowest is called a minimum. The highest is called a maximum. And again, I just want you to listen. So the top graph, this one right here has a maximum at the vertex, and this one has a minimum at the vertex. So then there's also these fancy words here, axis of symmetry. Symmetry means it's on the same side. If you look on each side, it's symmetrical, the same on each side. And this dotted line that goes through the middle at the vertex means that the left side looks the same as the right side, pretty much what happened with our absolute value graphs as well. So that's what the word axis of symmetry means. It's this fake line, that's why they dot it. It's a fake line that goes through the vertex, and it just means that each side, the left side, looks the same as the right side, okay? So that's what the axis of symmetry is. All right, let me erase some of this. Okay, the other things you should notice is where the x-intercepts are, and those are the dots on the graph where the red graph hits the x-axis. So those are the x-intercepts. A lot of this class will be focusing on the x-intercepts, but a little bit later on. Okay, so right now we're just going to practice how to do these graphs. But those x-intercepts are what we're going to study later. All right, and the point where the parabola changes direction, that's called the vertex. So the vertex is either the highest or the lowest point. And it's just where the graph changes direction from going downwards to upwards. In this case, from going upwards to downwards. So the idea that something changes direction is just the shape of the graph, and that's very important for calculus. So if you're going to advance on into pre-calculus, the ideas of changing direction is very important. What you need to know is where that vertex is, okay? Now what we're going to be studying is over here, the vertex is where the point HK is. So we're going to be reading the vertex right from our equation. Okay, and we'll get into that next. Okay, so now I would like you to start writing. If you can have your paper and label it notes number 34, please. And I would like you to write down the words vertex form and then the function that's below it. So these are parentheses, and don't forget this little 2 up here for the square. It's very important that you notice that this equation has parentheses and a square there. Otherwise, you're going to notice that A, H, and K are in the same positions that we've been working with before. So you can go ahead and hit pause if you need a minute for that. Okay, we're continuing in notes number 34. If you can write this entire screen down, this is the steps to graph a quadratic function. So number 1, you're going to graph the parent function. So we're going to have to learn again how to graph a parent function. You're going to describe the transformation. Does that mean up, down, left, right, stretch, shrink? We're going to plot the vertex, h comma k. We're going to label whether that is a maximum or a minimum. And then the last thing we're going to do is we're going to stretch, compress, or reflect. And we'll get into that tomorrow. So I want you to go ahead and write down those 4 steps. If you like, you can just hit pause. Okay, so I want you to just hold on for a minute. So now these look like the same graphs as before. I want you to go ahead and draw them, and I want you to label the vertex and the x-intercepts. Hit pause, please. So draw 2 graphs, one that opens up, one that opens down, and then you can label where the x-intercepts, the vertex are, and then come back to the video, please. Okay, so the other thing that we want to label is whether these graphs have a minimum or a maximum. So you can see that this graph goes all the way down and then comes back up. This is the very first graph right here. So the graph goes down and then goes back up. So this graph has a lowest point. So this vertex is a minimum. So add the word there, minimum. The next graph, if you follow along, and when you follow along with the graph, you're always supposed to start on the left and go to the right. So it goes all the way up and then comes back down. So this graph has a maximum. So this is what your standard graph should look like, curved, not V-shaped, and that you should be able to identify where a minimum and a maximum is. Okay? And the x-intercepts, again, are just where the dots, where the graph crosses the x-axis, and then your highest point here is called your vertex. Your lowest point over here is the vertex, and then you have some x-intercepts. Okay? You can hit pause if you need more time. Okay. Let me just change colors here. So I'd like you to go ahead and write down this equation and parent function. Please make a t-chart. And inside here is where we put our parent function that we're going to graph for our t-chart. Please go ahead and draw a coordinate plane so that we can actually graph this. And I'll do it just like you, by hand graph if you don't have graph paper at home. Okay, so we're going to go ahead and pick -2, -1, 0, 1, and 2. And again, I'll be talking about the numbers that we're choosing later on. So now we're picking that value for x. We're going to plug it in right here, and we're going to do the math. So y would be equal to, what is negative 2 squared? Now, when you have a negative number, you should always be putting that in parentheses, okay? This one will be negative 1 squared. The next one will be 0 squared. So we're plugging that in for that x value right there. This one will be 1 squared, and the last one will be 2 squared. Okay, so what is negative 2 squared? It means negative 2 times negative 2, that's 4. Negative 1 squared, that means negative 1 times negative 1, it's positive 1. 0 squared means 0 times 0, which is 0. 1 squared means 1 times 1, that would be a 1. And 2 squared at the bottom, 2 times 2 is 4. Okay, so now we're going to go ahead and graph these points. So we put those together, negative 2 and 4. Let's go together as a dot. Whoops. Next one is negative 1, 1, 0, 0, 1, 1, and then 2, 4. And then we'll go ahead and make those dots on the graph. Okay, left 2, up 4. Left 1, up 1, 0, 0, over 1, up 1, and over 2, up 4. And then you have to make a smooth curve. This is not V-shaped, okay? So I'm going to put it over here so that you can kind of see this a little bit better. And then if you watch carefully, I'll show you how to make this smooth. To make it smooth, just always smooth out the bottom first. So you smooth out the bottom and then bring it up. And I missed a dot, and that's okay. I'll just move my dot over a little bit. There we go. Let's make my dot a little bit bigger. And big dots are good. Very easy for Miss Arto, for Miss Fairbanks to grade. And so you just smooth it out and then shoot it upward. So this should be smooth shaped, curved at the bottom, not V-shaped, okay? So this is the parent function. So we did the parent function on absolute values. So I kind of really missed that one there. I should probably try and do a little bit better. There we go. So you need to remember these numbers, because what we're going to do is we're going to plot those parent numbers. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. And then we're going to plot those and be able to move our graph. All right. You can hit pause if you need a moment. Okay. So we're going to use A, H, and K to graph this one. So go ahead and write down this function on your paper. I'm going to draw a grid. Do it just like you. Okay, so according to your steps, we need to identify your transformations. So let's identify A, H, and K. So this position next to X inside the parentheses is always H, and on the outside is always K. In the front is A. A is just a 1, so we can ignore it. If A is a number like 2 or 3, it's going to stretch it. If A is a fraction like 1/2 or 1/3, it will shrink it and make it wider. So right now we're not going to deal with A. We're just going to leave A as 1. So H is negative 3, because it's always opposite of what you see. It's going to move it left 3. K is 0, so there's no movement up or down. Okay, so H and K is going to define our vertex. So these two numbers are going to become our vertex. Write that down. That's very important. So it's going to be -3 and 0 because our vertex is always h comma k. Please write down this at the bottom. Vertex, -3 comma 0. And you should put underneath there that the vertex is h and k. So we always label that. Okay, we'll decide whether this is a max or a min, and we'll circle that in just a minute. Okay, so let's go ahead and put our parent function dots, 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. So this is just like we did with the other graph. For absolute value, now we're going to just go ahead and make the movement. So we have to shift all those dots to the left 3 times. So I'm going to change colors. And I'm going to start with this dot right here, and I'm going to go left 3, then I'm going to move this dot, I'm going to go left 3, and then I'm going to do my vertex, left 3, and then I'm going to do the other ones and just make them symmetry across. So I shifted each dot left 3. Smooth out the bottom. Whoops. Oh boy, I have to redo that, don't I? Hold on. There we go. Sorry about that. Smooth out the bottom and then just move it up. So you want to smooth out the bottom. There you go. Your graph shifted left to the left 3. Okay, so let's decide. Is this a minimum or a maximum? If you start at the top left and draw the graph going down, it goes down to the bottom and back up. So this is a minimum. Please label minimum. Okay, let's go to the next one. You can hit pause if you need a minute. Please write down this function right here. Draw out a graph. I'm going to put my parent function dots here. It's normally at 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. So those are our parent function dots. Again, this is your H. Your K is always on the outside. H is opposite of what you see, so it's going to be, whoops. It's going to be +2, so that means we're going to go right 2. A is out here, and it's just worth that hidden 1, so we don't need it. K is 0, so there's no movement, up or down. Okay, so these two numbers are your vertex numbers. So our vertex is going to be at 2, 0. Because remember, H and K over here is where your vertex is. Okay, and H is always opposite of what your eye sees. So you see -2, but you use +2. Okay, so that just means that each dot on the graph is going to move to the right 2. So we'll just move each one right 2. There's one up here, one over here, and your graph moved to the right 2. There we go. And again, this one has a minimum because our graph falls down to the lowest point here and then comes back up. Okay. All right, we're going to move on to the next one. You can hit pause if you need to. Please write down this function. Draw your grid. I'm going to put the parent dots on. The red dots are our parent function. So this is the position of H. Let me change color. I'm not happy with that. There we go. H is always by the X. K is on the outside. You can kind of think of this as x plus 0 squared plus 1. That would be the exact same thing, because if you added 0 to something, it does not change the value. So now you can visually see that h is a 0. Remember, h is always next to the k. I'm sorry, h is always next to x. K is always on the outside. Okay, so h is 0, so there's no movement right or left. K is positive 1, so it's going to go up 1. Sorry, I wanted to write a 1 there. So that means up 1. And remember, these two numbers, h and k, represent your vertex for the graph. Remember, that's what we're finding, and that's what makes the vertex. Should be rather easy. So these are your vertex numbers. So 0, 1. So you just take the graph, and it says to move it up 1. So we're going to take each dot and just move it up 1. So each dot's going to go up 1. That's all. There we go. The graph shifted up 1. And then again, right here we have a minimum, because the graph has a lowest spot right there at 1. You can hit pause if you need to. Okay, go ahead and write down the next function. Draw your grid. Make sure you put your parent dots on there. So 0, 0, 1, 1, 2, 4, negative 2, 4. That's the position for h. This is the position for k. There's no h, so h is 0, k is negative 4. The k number never changes. It's not counterintuitive, okay? Only h is counterintuitive, opposite of what you see. So the k number is just what you see, and in the back is negative 4. So that means we're going to go down 4. These two numbers make our vertex. So our vertex is at 0, negative 4. And so we're going to just take the parent function dots, and we're going to move each dot down 4. So I'm going to start here at the 0, 0, 1, 2, 3, 4. Then there's a dot to the right, dot to the left, and a dot up and over. And there we go. We moved our graph down 4. I'm going to make that one a little bit smoother there. There we go. And put arrows on the end. So the whole graph shifted down 4. Again, this has a minimum. How come we haven't had one with a maximum? How come? What makes a graph have a maximum? You don't have to write this. I'm just kind of talking for a minute. Maximum would be if we had A has that negative in the front to turn the graph upside down, and we're not going to do that today. So that's why none of them have a maximum today. Because to have a maximum, you need to be upside down. Highest point is a maximum, right? And in order to turn a graph upside down, that A value in the front has to have a negative. I think that's all I have for you today. Oh, one more. I was wrong. One more. So this one we're going to shift both ways. There's an H and a K that is not a 0, right? All right, so let's do one more. Draw a grid. Put your parent function on there. There we go. So 0, 0, 1, 1, negative 1, 1, and 2, 4. That's it. Okay, so this is the position for H. This is the position for K. H is always opposite. So you see positive 3, use negative 3. That means the left 3. K is positive. Oops, boy. K is positive 2. So that means up 2. And those two together, H and K, make your vertex. So we're going to put negative 3, comma 2 as our vertex. This one's going to have a minimum 2 because it's going to be opening up. Okay, so you're going to move each dot left 3 and then up 2. So left 3, up 2. So I'm going to start at this dot right here. So left 3, up 2. Left 3, up 2. Left 3, up 2. And then you would know it would turn, so symmetry says my other dot should be right here, and I'll just turn them up. And put arrows on the end. So did the whole graph move from the red dots left 3 up 2? They sure did. Okay. If you want your graph to look nicer, you can get rid of the parent dots. That's okay too. I mean, they're just there for reference, right? Oops, got rid of the whole thing. I can draw it back in. So those parent dots are just there for your reference. Okay, well, thank you for notes number 34. You guys will practice this more tomorrow. So we're going to have to practice when this graph turns reflects over so that we can end up having some maximums. Today we only had minimums. Thank you. Make sure you upload your notes, okay, to the digital workbook, and that those images are very clear so that we can see them, okay? Have a great day.